셋, 별.
Write an equation that expresses the temperature T as a function of the altitude xm. As shown, the red temperature changes equal to 6.5 degrees Celsius over 1000 m. We know that the red temperature changes equals to temperature changes, which means the equation of 6.5 over 1000 equals to temperature change over altitude. When we want to know the temperature change, the altitude will then be times to the equation of 6.5 over 1000 m. Then, the equation of temperature change is 6.5 over 1000 times altitude. The initial temperature is 30, where the altitude is 0 meter. An equation that expresses T equals to 30 minus 6.5 over 1000 times x, which is the altitude. B. Verify that your equation in A is reasonable by using the data provided in the diagram. So from the equation we just found, we put x 1000 into the equation equals to 23.5, and when the x is 2000 equals to 17, and so on. This shown that the equation is reasonable because we got the same answer from the data above.
Alright, now we will use the data given in the figure. The data will be translated in point coordinates. In the graph, we will label the horizontal axis with altitude, which is x meters, while for the vertical axis it will be labeled with temperature T degrees Celsius. On the horizontal axis, 2 cm is equivalent to 1000 meter, while on the vertical axis, at every 2 cm, it will represent 20 degrees Celsius. Next, we can start plotting the points. After we finish plot the points, we connect all the points in a straight line, and that's how the graph is formed. And now, question D. What is a reasonable range for the function Tx? So the reasonable range for the function Tx is 4 Celsius is less than or equal to Tx, and Tx is less than or equal to 30 degrees Celsius. This is because the height of Gunung Kinabalu is about 4000 meters. From the information, it said that at 0 altitude, T equal to 30, which means T is not more than 30 degrees Celsius.
Question E. What is the gradient of the graph drawn? What is the meaning of the gradient of the graph in terms of temperature and altitude? So we know the formula of gradient is y2 minus y1 over x2 minus x1. From the graph, I put the coordinate of 0 as x2, 30, y2, 2000, x1, 17, y1 equals to 30 minus 17 degrees Celsius over 0 minus 2000 m equals to negative 6.5 times 10 to the power of negative 3 degrees Celsius over m, meaning every 1 meter up, the temperature decreases by 0.0065 degrees Celsius. Question F. What is the y-intercept of the graph drawn? What is the meaning of the y-intercept in the terms of temperature and altitude? So, from the graph, the y-intercept that is marked is 30, meaning the temperature at the sea level of 0 meter altitude is 30 degrees Celsius. Question G. Is it reasonable to assume that temperature always decreases at a linear rate as the altitude increases? Yes. Since the relation between T and X is a linear function, the temperature decreases at a linear rate as altitude increases in the troposphere. This means that the relation of T and X is a linear function because we could see from the graph it is a straight line. Meaning when the straight line occurs, it is a linear function, which means there is a relationship between the T and X.